Hey guys, we're back with the notes for 11.1. Today we're going to be talking about exponential functions. This is the third kind of function that we've talked about. So the first semester, we hit y equals mx plus b. That was linear. Every graph was a straight line. Then we talked about y equals x squared. Those were parabolas, and that was called a quadratic function. So our last topic is called exponential functions. Basically, we're going to take the x now and put it in the exponent. So if you would, go ahead and pause the screen for just a second, copy what you see, and then we'll get started. Perfect. So at this point, you should have everything written down. What we're going to do is talk about finding these values and these pieces of information from an equation and from a graph. So from an equation, it's very easy. Your initial value is the first number. It's outside of the parentheses. It comes first. Second number is your multiplicative rate or multiplication rate. That number is the one in the parentheses or the number holding the exponent. Obviously, your x, the variable, is the exponent. Let's move down for just a second. My initial value is always going to be where I start on the y-axis. So let's try to do these answers from graphs only. I'm going to erase the equation so you can't see it. All right, so on the first problem, if I look on the y-axis, I notice that I start at 5. That means my initial value is 5. If I look at the next problem, I'm saying where am I hitting the y-axis? It's between 0 and 3, closer to 0. We're going to say that's a 1. Last problem, I'm going to look on the y-axis. I start up here at 8. That's my initial value. That's all we're doing. Just where did it start on the y-axis? Okay. The second part, my multiplicative rate, I'm looking for whole numbers. So I'm saying where does 1 go, where does 2 go? So if I look at problem 1, my 1 goes to 10, my 2 goes to 20, and my 3 goes to 40. So the question is, every single time, what am I multiplying to get to the next number? 5 times 2 is 10. 10 times 2 is 20. Times 2 is 40. So every time I'm multiplying by 2. My multiplicative rate is 2. We're going to say that because that number is bigger than 1, I'm growing. So my numbers are getting bigger. That means that this is growth. Okay? Let's look at the next one, problem 2. If I say, where does 1 go? It hits at 3. Where does 2 go? It hits at 9. Where does 3 go? It hits at 27. So every single time these numbers are getting bigger, every single time I am multiplying by 3. So because 3 is bigger than 1, and 1 is just the number I use all the time, so because it's bigger than 1, it's growing. Okay. All right. So this last one's a little bit different. When I look on these, I know it's skip counting. So let's see if we can go tally, 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 tally. All right. So if 0 goes to 8, where does 1 go? Hopefully you see the 2. Where does 2 go? Well, if this is 1, it's on the line below that. So that means it's at 0.5. So the question is, what am I multiplying by to go from an 8 to a 2? A lot of you are going to look at that and think that you're dividing by 4, but I want you to think it has to be a number smaller than 1, and it has to be multiplication. So what we're going to say is I'm taking 1/4 of it. So I'm multiplying by 1/4. What that does is it makes all of my numbers get smaller. Therefore, because 1/4 is smaller than 1, we are decay. 1/4 is my multiplicative rate. Now, all of these would have been really, really easy to find if I was looking at the equation. So my initial value would have been 5. My initial value would have been 8. My initial value on this one, though, is a little bit tricky. There are no parentheses. So let's say I put b in parentheses. What number would be out here that we don't usually write down? Hopefully you remember that that's a 1. So 1 is my initial value. All right, so what about my multiplicative rate? Well, my multiplicative rate, remember that's the number that's in the parentheses. So I had a 1/4, I had a 3, and I had a 2. Those are my values I'm looking for. Okay? If you need to pause the screen, write it down. Go ahead and do that. Otherwise, I'll meet you on the next page. All right, if you would please, go ahead and copy what you see, and then we'll get started. Perfect. At this point, you should have it written down. This is to remind you the difference between growth and decay. Exponential growth is whenever b is bigger than 1. It does not matter if a is negative. You might be above the x-axis, you might be below the y-axis, but we are growing as long as my graph is moving away from the x-axis. Okay, so you might be growing in the positives. Maybe you're making money. You might be growing in the negatives. Maybe you're growing in debt. Maybe you're a college kid and your student loans are racking up and racking up. That's growing. It's just growing in debt. Okay? Decay is a little bit different. Decay means that your b value, your multiplicative rate, is between 0 and 1. Okay? So what that means is maybe I am paying off my debt. I might be in the negative side, but I'm paying off my debt. Or I could be depreciating a value on a car. So let's say I buy a new car and every year it loses a little bit of its value. So over time, its value is decaying. All right? So it could be positive, could be negative. All we care about for growth or decay is the number in the parentheses. Bigger than 1 or smaller than 1. Here is the most important rule though. Most important rule is that b cannot be negative. So you can have an equation like y equals negative 2 to the 3x. That's fine. What you can't have is y equals 3 to the negative 2. Or sorry, 3 times 2 to the, oh my lord, 3 times negative 2 raised to the x. The problem is this part right here. b cannot be negative. Okay, so when you see your homework, if you ever see a negative number in the parentheses and it asks you if it's exponential, here's what you do. You just say, no, it's not. And then you skip the rest of the question. I can't answer the questions if they don't apply. All right, let's try and show you real quick what that would look like if you tried to graph it. So I'm going to move this real quick. Maybe not. Is it open? There we go. This is what your graph would look like if you tried to do problem B. All right, your graph is trying to go back and forth between negatives. So we talked about a negative squared is a positive, but if I raise it to the 3rd power, if x was 3, it would go negative. To the 4th power would be positive. To the 5th power would be negative. Negative, positive, negative, positive. Do. Back and forth, back and forth. Okay? Calculator can't handle it, so we don't worry about it. It's not exponential. Okay, let's try A. So on A, you have the same, let me copy these. You have the same 3 questions. Or sorry, 4 questions, I guess. Same 4 questions. So let's go through these. On A, is it exponential? Yeah. B's positive. We're good. Is it growth or decay? Well, that all has to do with this number. So because that number is bigger than 1, that's a growth. My A, or my initial value, is 1/2 because it's outside of the parentheses. My multiplicative rate is 2 because it's in the parentheses. That's all you're doing. Okay? For C, is it exponential? Yeah. My parenthesis number is positive. We're good. But 0.75 is smaller than 1. So I'm going to say that because it's small, that's a decay. My initial value is what's outside the parentheses. That's a 2. Multiplicative rate is what's inside the parentheses. That's 0.75. Okay? That is your assignment. That's all you're doing. You have, I think, 6 questions that look like this. And then you have 4 questions that look like these graphs. So make a dot for the initial value on the y-axis, and then figure out what you're multiplying by to get to the next number. Remember, if it's smaller than 1, it's decay for B. If it's bigger than 1, then you're growing. Okay? All right, your assignment is 11.1, page 167, 168. If you have any questions, go ahead and come see me. Otherwise, you are ready to roll.